All right, this is Ready for High School Math Lesson 2.1 on solving one-step equations. All right, so far we've talked a little bit about evaluating an expression, and that is given an expression and given a value for a variable, we would plug in that variable and determine what the value of that expression was for that variable. So now instead it's going to be almost kind of a flip of that. Instead of us being given a variable to plug in, we need to figure out what the variable needs to be itself. Okay, so let's get started. So first up, we got a definition. The solution to an equation is the value that can replace a variable and make the equation true. Okay, so an equation right here, that maybe is a new term for us. So an equation is basically if we take two expressions and set them equal to one another, we connect them with an equal sign. Okay, so in the past, we just had an expression. An expression would be something like maybe something as simple as 5 or x, or even a combination of them like 3x plus 2. But an equation comes along and it's going to take two of these and set it equal to each other. So for example, 5 equals 3x plus 2. So the main difference is this equal sign. That equal sign is what connects the two expressions together. So when we're talking about the solution to an equation, the solution is going to be a specific value that we can plug in for the variable, okay, so the letter, and we can make the equation true. So in order to solve this equation, we need to isolate the variable, and when we isolate the variable, we want it to have a coefficient of 1. That is, we want the number in front of it to be a 1. So in this case up here, how the number was 3. So in order for us to have this thing fully solved, eventually we would need to do some work and finish it out to where it looks something like x equals some number. Okay? All right, so let's get straight into it. Let's talk about how we can go through and solve these things. Okay, so number one, we have p plus negative 12 equals negative 5. Okay? So first things first, what I would do in this situation is notice that there's something that's a little bit redundant. So anytime we have plus a negative number, that's just a little bit redundant. It's not necessarily wrong to say that. It's a little bit more than we actually need. It's a little bit extra. So instead what we can do is if we have plus minus, in this case right here, we can go ahead and change that to just a minus. Okay, adding a negative number is the same thing as subtracting the positive. And frankly, I know I just prefer seeing p minus 12 rather than p plus negative 12, just because there's less signs to worry about. All right, so now let's look at this thing. So in order to solve this equation, we need to do something to get it to where it's just p equals a number. So in order to get p alone, that's the whole plan, we need to get everything that is on the same side of the equal sign as p away from p. All right, so if we look, we have p minus 12. So 12 is being subtracted from p. So the trick here is that to get this away from p, we need to do the opposite of what is currently happening to 12. So 12 is currently being subtracted. So the opposite of subtraction will be addition. So instead of subtracting 12, we need to add 12 to get rid of it on the left-hand side and get p alone. But in order so we don't change the value of anything, whatever we do on one side of the equal sign, we also need to do on the other. So if I add 12 to the left side, I need to add 12 to the right side as well. So when we do this, p minus 12 plus 12, these will cancel out, and we're left with just p. And then we have negative 5 plus 12, and that is going to equal 7. Okay? So 7, that's what we got for our value. P equals 7. So at the moment, we have potentially solved, sorry, there's a little bug there. We have potentially solved our equation. Now we need to go through and just check it. So what we can do is we can take this value of P and we can plug it back in to the equation. Okay, so if we plug it back in, we're going to get 7, and put it in parentheses. Anytime we plug a value in, we always put it in parentheses, plus negative 12. I'm just going to rewrite it exactly as is, and then we can come around and type that in the calculator. 7 plus negative 12, and we get negative 5. So if we notice, we had negative 5 when plugged into the calculator, and negative 5 over here in our original problem. So we know that P equals 7 is a good value for us. Okay, let's try another one. Next up, we had negative 7 equals r plus 16. Okay? So again, the goal is to get r alone. So we have to get everything that's on the same side as r away from r. So right now we have r plus 16. 16 is being added to r. So to get r alone, we need to do the opposite of adding 16, which will be subtracting 16. So we're going to subtract 16 from the right side, and that's going to get the r alone and leave us with just r. But again, so I don't change the value of the equation, the value of my answer. Anything I do to one side, I need to do the other. So if I subtract 16 from the right-hand side, I need to subtract it from the left-hand side as well. So I'll get r by itself on the right-hand side, and on the left-hand side, negative 7 minus 16 will give me negative 23. And once again, I can go back through and check my answer. So if I type that in, we'll get negative 23. Again, always remember the parentheses, plus 16. So this time I typed in the right side of the equation. You're just going to type in whatever side of the equation had the variable. And you see, I got negative 7 here, and negative 7 was in my original problem. So we know that negative 23 equals r. That's a good solution. Let's look at number 3. X minus 8/5 equals negative 2/3. Okay, so this one, it looks a little bit more daunting. It looks a little bit harder because of those fractions, but we're going to work it out the exact same way. Okay, so we're trying to get x alone. Right now, 8/5 is being subtracted from x. Okay, so in order to undo that, we need to do the opposite of subtracting 8/5, and the opposite would be adding 8/5. And anything we do to one side, we need to do the other. So we're going to add 8/5 to both sides. Okay, so on the left-hand side, these will cancel out, and so we'll get x equals. Now, this one might be a little bit hard to do by hand, so just use your calculator, make it easy on yourself. Okay, now, anytime that we are typing in fractions into the calculator, always make sure to put it in parentheses. Okay, and a good rule of thumb is just always put anything in parentheses. If you're unsure about it, put it in parentheses. Parentheses will not necessarily always help you make it more right, but it'll help you to not make it wrong. So negative 2/3 plus 8/5. Now you notice I get a decimal answer. I get a repeating decimal answer. 0.93333 repeating. Okay. Now we could put that down for our answer, but that's a little bit long. Okay, that's a little bit long. It's a little bit cumbersome. We don't really like that answer. So what we can do instead, to get the simplest fraction form of this decimal, we're going to hit math, and then down here, off screen a little bit, enter. And once we do that, we are given the simplified fraction form of this decimal. So 0.933 repeating is the same thing as the fraction 14 over 15. Okay, so now we go through and check and make sure 14 over 15 is a good answer for us. So 14 over 15 minus 8 over 5, plugged it into the left-hand side, equals, so now we get negative 0.6 repeating. We didn't get negative 2/3, okay? So at first you might think that our answer is wrong, but once again, let's check and see. Math, enter. So anytime that you're typing in a value like this, even if you're using fractions, it's not always going to give you, in fact, it probably never will give you a fraction answer first. You have to ask for the fraction answer by doing math, enter. Because I can see negative 0.666 repeating. That's not what we started with, or it didn't look like that's what we started with. But once we did math, enter, we got negative 2/3 and negative 2/3. Okay? Let's keep on going. All right, so next up, this one right here. So number 4, they gave us a step-by-step process, and they want us to fill in the reasons. What was the reason for each step existing? So we started with the equation, negative 3.2 equals y plus 0.2. Okay, so that is before they have done anything to the statement. Therefore, this is known as our given statement. This is a statement that was given to us or given to whoever solved it first. Now, in this statement, their plan was to get y alone. So y was being, 0.2 was being added to y. So to get the y alone, they had to subtract 0.2 from both sides. So they did that. So from this step to this step, or in this step, they were subtracting or the action of subtraction was happening. And then once they did that, they were left with negative 3.4 equals y. Okay, and so now in order for them to check their solution, they had to go back through and use the action of substitution. Substitution is just a fancy word for plug the value back in to check your answer. Okay, so let's work this one on our own. Negative 8 minus y equals 13. Okay, so keep in mind, eventually we want to get the coefficient with the variable, in this case y, to be a positive 1. Okay, so let's work through that. All right, so first up, we need to get the y alone. We need to get the y alone. So right now we have negative 8 minus y. So let's knock out that negative 8 first, okay? So in order to knock out that negative 8, we're going to add 8. Anything we do to one side, we got to do to the other. So we'll cancel out, and we get negative y is equal to 21. Now, initially you might think, well, that's done. We've gotten the variable alone by itself, but the one thing that we haven't done yet is this thing is negative. Remember, whenever we have this thing fully solved, the coefficient has to be positive 1, not negative 1. Okay? So, anytime that we have the variable by itself, like in this case over here, we know that the understood coefficient is meant to be 1. If there's no other visible number present in front of a coefficient, it's understood to be 1. So in this case, there's no number visible. All it is that minus sign. So this isn't meant to be 1y. It's meant to be negative 1y. And negative 1y means that we're not done with this one yet. So negative 1y, that's the same thing as saying negative 1 times y. So this time, to get y alone, we need to do the opposite of multiplication because negative 1 is multiplying to y. So the opposite of multiplication is division. And so we're going to divide by that thing. So negative 1 divided by negative 1, that will become positive 1. Anything divided by itself will give me positive 1. And then 21 divided by negative 1, anything divided by negative 1 just becomes the negative version of itself. So we get y equals negative 21. So now we'll go through and we'll list the reasons for each step. Okay? So we have our given reason, negative 8 minus y equals 13. That was our first statement. Okay, then the next step was we were adding. We used this addition to get to this next step, negative y equals 21. And then from here, we use division because we had to divide both sides by negative 1. And then lastly, once we got to this step, in order to go back and check, we would need to use substitution in order to do that. All right, next step, number 6. Write an equation and solve. A number increased by 8 is negative 21. What is that number? Okay, so we did a lot of these back in Unit 1, taking a phrase in English and translating it into a phrase in math. So we have a number increased by negative 8, so let's focus on that a little bit first. So a number, anytime we have some kind of a number that we're unsure about, we use x. Now it says increased by negative 8. So anytime we are increasing a number, that means we are adding something to it. And in this case, we are adding negative 8. So I'm going to put that negative 8 in parentheses. Now we have is negative 21. So anytime you see the word is in a sentence like this, is represents an equal sign. Okay, you don't necessarily always have to write the word is above it. I'm just doing it in this example. So anytime you see the word is, it always represents an equal sign. So x plus negative 8 is or equals negative 21. So we translated our phrase into an equation. So now we'll go through and we'll solve that equation, okay? So x plus negative 8 equals negative 21. I'm going to change this since we got that plus minus. I'm going to change it to x minus 8 equals negative 21. Just to get rid of one of those signs that we don't need. So in order to get x alone, we need to get the negative 8 away from the x. And in order to do that, we need to cancel out the negative 8 with a positive 8. So that when we do that, the 8's will cancel out. And so we will be left with, and I'll bring my answer over here, x is equal to negative 21 plus 8. And that is going to give me negative 13 for for my answer.